Welcome to the Circuit News. 900 million acres across the United States are used to grow the food that we eat every single day. But now a vertical farming company in California is using technology to change the future of agriculture. Plenty is designed to grow 4.5 million pounds of pesticide-free leafy greens every single year indoors within a single city block here in Compton, California, making this the largest indoor automated farm within the entire world, and that process is kicking off right here behind us. They also bring the power of the sun indoors by engineering the sun's nutritious light.
We have to be ruthless with the efficiency of our lighting system because that is something that traditional agriculture really has an overabundance of.
I build and design the lighting controllers here in the farm. So we have the right timing and the right brightness and spectrum. It's really cool to be able to interact and really understand the plants in that way.
Plenty is a completely indoor vertical farm that has the potential to save millions of gallons of water annually and is expected to yield 350 times more per acre than conventional farming. Pulling weeds by hand, it's not always fun, but now there's a machine that can kill 200,000 weeds an hour using lasers. Carbon Robotics Laser Weeder can zap weeds across 2 acres in an hour, while it would take farm workers over 50 hours just to get through 1 acre.
The way that the machine works is that we have an array of very high performance, high-powered CO2 lasers. These are 150-watt lasers, 10.6 micron.
The automated machine attaches to the back of a standard tracker. The lasers have several cameras and it uses deep learning computer vision algorithms to target the right plant, protecting the crop and soil. We know nitrogen can help make for a great cold brew beverage, but it's even better for growing our food systems. But too much can attract pests or create toxic environments in nearby ecosystems like algae blooms. Iowa State has now teamed up with Ingenious Ag to create handheld sensors that can tell you in seconds how much nitrogen a plant needs by plugging it into the plant. Meanwhile, mechanical engineering professors Jonathan Clausen and Carmen Gomez are finding more affordable ways to manufacture biosensors that are not just used for agriculture but in food safety and health applications.
Fertilizer can be up to a third of the farming cost.
So the method that we have developed is scalable. It's a way that you can produce multiple thousands of sensors at once using materials that are readily available. So it's a type of sensor that you can just implant in the soil. It's like what we like to call bury and forget.
These are just a few of the many digital solutions researchers at Iowa State University are working on for agriculture.
We have agronomists and engineers and computer scientists working together every day to solve challenges in digital agriculture.
The university works with major agriculture companies like John Deere and Soil Tech to improve data and automation in the industry. Now here's a farming technique that's out of this world. 3 universities are teaming up to bioengineer microbes that could feed space travelers. As NASA is preparing to send humans to travel across the solar system, engineers have to figure out a way how to feed these people in outer space. In SpaceX's most recent launch, it cost the Falcon Heavy spacecraft $5,000 per kilogram in food for low Earth orbit, and the cost for Mars is expected to be closer to $18,800 per kilogram. The University of Florida, along with the University of Delaware and UC Berkeley, are part of the program Be Sure, taking into account the different levels of gravity, radiation, temperature, and pressure. The end goal is to be able to manufacture and grow a source of essential nutrients, medicines, and vitamins in the most energy-efficient way possible. Thanks for watching. We'll see you again right here next week at Circuit News TV.